Hello everyone, today I'm going to show you guys the fundamentals of Wi-Fi, WLAN, wireless local area networking traffic. The deeper explanation is mentioned on this website. As we know, most routers use a local area network, also called LAN, to manage all the systems and devices inside the router. So by this means it's very important that we will find a way to understand the fundamentals and also analyze the network traffic by itself, and also to understand the underlying functions and response and receiving packets which are displayed in the network. So let's get going, and I will explain you guys the fundamentals for that you guys will understand the implementation of protocols and everything Wi-Fi WLAN related more easily. Hello everybody, I'm gonna explain you guys common C network protocols in the local area networks or wireless local area networks. So they are used and integrated inside the network infrastructure of the local area network, and they all have their specific functions and ways that they do the packets. So one of the most common functions they CP assigns IP addresses and network configurations like the MAC addresses to be shown on the network. And there's also DNS which resolves domain names like website names to IP addresses or vice versa. And there's also the ARP request protocol, which resolves IP addresses to MAC addresses and announces it on the local network that you can see if you sniff with Wireshark. So that's basically how protocols work. And those are commonly seen website-based protocols. One is a HTTP. It is commonly used for intercommunication for retrieving web pages. And it's on the transport protocol port number 80. And HTTPS is just a form of it which is secured and has encryption, and it goes on the transportation protocol 443. And those SSL encryption and TLS encryption which are used for this are commonly used for higher security or specific. They're in conjunction or integrated inside the HTTPS, but it depends on SSL or TLS which one is specifically used. But they are used to encrypt the communication of the web server and also the a browser that you use as like Firefox, Chrome, and so on. So that's basically how the protocols work. And if you want to have a deeper understanding and learn it and analyze it, and also really understand for packet injection or modifying the traffic or manipulating it, you will need to read the RFC about it. And that's very important to know. So if you guys understand it, just skip it. what we have here is a graphical flowchart of the Wireshark tool. So I'm gonna explain everything what is going on here. So first of all, the NO dot in the orange color here is used to measure the packet timing and overall the timing of the packets, how under any time zone they stand. The source is the client which sends the traffic to the destination of the server. But the source address is also addressed in any kind of IP address or any internet protocol which can send itself the data to its destination. And the destination is the one that receives the data from the source, not a client, but like but it depends. Sometimes it can be a client, or the destination could also be a client which receives something. So to explain it better, it's like if you send a packet from yourself to the destination. So there also importantly is to know the protocols in the red one here. And the protocols are the transport protocols used to transport the application data to there's like specifically protocols. As you can see here, there are many different kind of protocols that exist, and they all have their different packets and flag function as how the behavior of the transmission works. And as you guys can see here in the purple one, there's the length of the data, how much of the data that gets transmitted in the network. And then we also got the brown one, is the info chart, which shows the protocol's application data information, or as how it sends the data in text format over the network. I mean, Wireshark can have deep packet inspection and read all the protocols. It's very useful to read the overall chart and understand the underlying forms. And as you guys can see here, that's the information, the more specific and explained in detailed information about all the layers that exist there. I will show in the end of the clips and also explain more deeply about how it works. But as of now, I just want to explain the flowchart of the Wireshark tool, how you need to understand it, or how can you read it out and also get the fundamentals out of it, or the basic that you can even understand everything here. Hello, today I will show you guys how to analyze the Wireshark networking traffic, and I have internet connectivity as you guys can see here. And if you open the CMD command prompt, which is used to do specific commands, but I want to use it to show my wireless card inside my computer, which is as hardware. Then I will write ipconfig if you want to see if the interface of your wireless card. So as you guys can see here, the wireless LAN adapter Wi-Fi, it specifies my IP46 internet protocol and also my IP4 address, my link local IP46 address, and a temporary one, and also the subnet mask, which is the IP range. It is integrated with, and you guys can see here there's also a default gateway here. Default gateway is the gateway router of my, well, it's the router which you use to connect to your Wi-Fi. So if you see here and you try to connect to internet on the Windows machine, you see this is the router which I'm connected to, and inside the Wi-Fi I have in the local area network, my IP4 address is this one, and my default gateway is this one. So what happens is that this is basically the network layer where all the routing and the traffic and modifications from the router happen, and how it assigns your IP address in the IP range. It can go to 1 to sorry, not 1. 1 is the gateway, but it can go from 2 to 255, as you guys can see here, which is supported by the IPv6 address. I mean, this protocol supports, the internet protocol supports that. So after this, I will then show you how to analyze the traffic from the web page, gateway web page, and understand then the analyzed OSI models and layers, and I will explain you in good detail and how to understand it, and also for you guys to replicate, so that you guys don't need to watch many videos, because I want to show you guys how to easily understand it and make it be permanently easily understood. So first of all, we close the command line. Okay, there's some display filter we can do. I'm gonna use IP.address to specify the address. It's a option, and this you use to specify, and then we will write the IP address which we wanna target. So it can be the gateway or any IP addresses that are in the routing traffic or the network layer, and it can also be a public IP address, but I will use the gateway because we want to analyze the gateway web portal login. So it has a web login where we can modify the router information and stuff. And then I will also specify, this means like, and I want to listen to the HTTP protocol, which is the web application traffic protocol, and also the transport protocol, which is TCP. Or you can just do HTTP, and we can find out from the data which is inside what protocol it uses automatically. So if we write HTTP, we can just hit enter, and you guys can see it's of course empty. So we will go to the Firefox browser. We will go 192.168.1.1. So what I'm gonna do is go here, click on it for start capturing packets. You can save it or you can continue without saving. I'm gonna continue without saving. And then if you go Firefox and you hit enter, boom, as you can see, stop this one. You can see that's the traffic that you received from the web application, and also the network layer, which is the gateway. And now we will analyze the traffic. Okay, first of all, this is the transmission protocol, but it doesn't use specifically HTTP. In a network layer, it uses TCP and UDP, most likely. And also, this is the length for the data we will get, and these are the web request response that we are getting from the router. So it depends on the source and destination. So as you can see, this is the source IP address. This is our private IP from our computer, which is connected to router, and this is the destination where it goes to in the network layer, right? And the protocol is the transport layer, but the transport layer of HTTP is an application layer, as it is used from the Firefox application, so it can also be the Chrome application, Internet Explorer application software, which transmit the data with the underlying transport layer as TCP and UDP. And this is of course the web request we will get. So the request can be very universal. It depends on what you want to capture, what network traffic you want to capture. For a wireless capture, I will show you guys in a different clip, but now I will show you only the web application stuff. So as you can see, guys, if we arrive at the gateway, at the destination, and we get to the website, and we basically click on the website, right? Then we will receive a response from the gateway to our private IP on our Firefox browser with the HTTP protocol. 302 redirect. So those are HTTP responses, or actually web request responses, which show what they will do. So 302 is used to redirect your private IP from here when you arrive to the gateway. So the gateway IP will, the internal system has a web service which will, let's say, is pre-configured and programmed to send the specific traffic that we get redirected to this specific front-end page. And if you guys go to view page source, you can see the code and everything underlined with it. And the frame source, that's the source code. It is all in JavaScript, which it gets the web application options, which redirects us to the front end page here. So, but specifically, if we go to the inspect element and go to network and reload, and we go to login HTML, as you can see, it's a GET request, and we will get the server which redirects us, and also uses ASP programming language to transmit and also redirect our data to a specific to the specific front end page. So how can you see the data traffic on here, and how does the underlying OS models work? So I will explain it. If you go right here, you go here, you go down here to look at the traffic. So we will look at the redirect traffic, where we get redirected to the front end page. And as you can see, this is basically the physical layer, the first one. This is the layer which has the physical devices, which has this numeric value, and this looks like like a folder which it gets it from. And this is the interface. And as you can see, if we go the config rules, it makes it does the HTTP request and supports that, and also transmit in this way. And also the port, which is actually from the transmission, or like say the transport protocol, is used as the 80. And this is also the underlying versions of HTTP2, which this also supports. And as you can see, if we go to interface ID and open this, it's an interface Wi-Fi, as we see in the command line. If we do write ipconfig, right? And this is the internet layer. This is a data layer where we get our MAC address. Sorry, where we get our MAC address, and you can see the MAC address, which is the destination, is our private IP. It is an Intel Corporation adapter. It seems like to be from this manufacturer, and this is the MAC address which is specified to it. And this is also the source where the data gets transmitted in the data layer, which is the gateway IP, which uses the data layer MAC address and also the IEEE 802.11 protocol to transmit the wireless traffic in according with the other underlying OSI models that we will talk about after this to make the request or response happen. And this is the internet protocol, or also the network layer number 3. This network layer is used to do the underlying networking and routing of the traffics inside the router and the net mask and all the private IP addresses, which are devices or any hardware that have internet connectivity and get connected to the Wi-Fi internet. And as you can see, the source address is the gateway IP address, as you guys can see here, and the destination is my private IP, as you guys can see here. And also there are some flags which specify what behavior it will have, and there's a time to live. And the protocol, as you guys can see here, is TCP. So that's how we can find out if the protocol is TCP or UDP, which is used to also transmit the wall data, right? Okay. So now this is network layer 3. So this is the transport protocol number 4. This is where the TCP protocol or TCP payload is used to transmit the source port HTTP port, which is used for hypertext transfer protocol to be used with the gateway web application data, and also which has the web server inside, which is called the go ahead HTTP, as I mentioned before. And it shall send to the destination port 60,004, which is our destination private IP address. And then you can see all the sequence and the ACK request and the numeric values and the length of the data inside. So as you can see, you can see all the analysis and stuff, but I won't get too deep into this stuff because I will just explain the underlying OS models. And this is the hypertext transfer protocol. And this is the, I would say, application layer. And the application layer, which the Firefox browser interacts with the website link, where also you will receive the connection and where you will send the connection to even get the server of the web server of the gateway. As you guys can see here, the servers go ahead, and if you go to the redirect request, which is the request to redirect us to the front end page, as you can see here, this shows also as login HTML, meaning we need to, is a page which is used to log in. It's made in the HTML program language for web designing. If we open the redirect request, we will see some specific information in the status code, which is used to make the behavior as 302, and the response phrase is to redirect you to the specific page. So yeah, that's how it works basically. And if you can see here, the location which we will arrive from the redirect request, which takes us from the IP address number 4 here, and then also the gets interconnected with the TCP payload, which we get from the gateway to us to the location we will get redirected in the web application data request to the location where we will have the login page, as you can see here, the link, website link. And also the request URI which we will get is this website, of course. And the file data is 216 bytes. That's the data size, how much is made inside in the request and or response. And that's how basically the layers work. So very quick for you guys to understand. This is the application layer, also web application data which we receive from the Firefox interaction with the router and our private IP when we open the Firefox browser. There's the application layer, and this is the transmission layer. The transmission layer does all the TCP transmission, and also this is the network layer where all the routing and the traffic gets aligned, that it gets understood, that we will go to the that we get the source address information to the destination address, which is us, that we will get the redirect response and everything else. And this is the data layer which specifies our wireless card, MAC address, and other specific information, which then will be interconnected also with the network layer and other specifications. And this is the physical layer. The interface description of it is the Wi-Fi, and there's some other informations that we can get from it. So all of this interconnects together, and this is the way how everything works in a deeper level, and how we should understand this kind of network capture and traffic. And that's how we analyze and understand the underlying options. So of course, I didn't say all the underlying options, how everything specifically works, but if you are interested, you can Google it up and also find ways to understand and learn about it. But that's just my basic way of me explaining all the captured traffic that we have here. And as you can see, all the captured traffic have different request information and other stuff, which are used to make different options, different modifications. Hello everyone, today I'm gonna show the tool called HPing3. It's an advanced network diagnostic tool, or a tool to also bypass firewall, or to scan network ports, or also to manipulate traffic or inject packets inside the network, and also see what the response is. And also you can craft packets to have specific behavior or flags, or specific transmission control protocols like UDP and TCP. So if you want to see the help manual, you write HPing3 -H, and there you will see many different options which you can use to send specific crafted packets. So I'm gonna show you one option that we can use. So I'm gonna specify HPing3 and the IP address of the Windows machine that I want to scan, and then you will choose, for example, I will choose the scan option here. Is for scanning ports, scan, and then you will specify the ports until which one you wanna scan. So the maximum ports are like until 65235, and then you will specify the flags. But by normal standards, the tool will scan as a TCP in a TCP transmission control protocol transmission. But now I will hit enter, and we will see what ports are open on the Windows machine that I am scanning. And then, as you guys can see, those are the service name of the Windows machine, which are very known: APMAP and Microsoft DS. And those numbers, as you can see here, are numbers which respond to the ports that are not online or don't exist on the Windows machine. And this port is, I looked it up, it is used for Windows updating service. So this is very interesting, because normally when I do scanning with Nmap tool, it's also advanced network scanner, I cannot find this port. But with HPing3 you can find specific ports, and you can also modify many things to have specific packets that can bypass firewall, and you can scan ports that are usually not touched so easily. So that's my explanation. I hope you can understand some of it, and I will explain in the next clips how I do hex data packet crafting and sending it over.